Hello, everyone. We'll give everyone another minute or so to connect and get their audio up and working. We'll be back in about a minute to begin. All right. Hello, world. Can everyone hear me okay? Well, greetings from Harvard, whatever time zone you are in. Good morning or good afternoon or good night. So nice to see so many faces here today. This is the last of CS50's seminars on Python for the new year. Each of these has been offered at different days and times to give folks around the world an opportunity to learn a little bit about programming, a little bit about Python specifically, and ultimately a little bit about CS50. If during today's seminar you find yourself a little bit lost or confused or you have technical difficulties, not to worry. Everything will be made freely available on the website thereafter, so that you can follow along again at your own pace. In addition to asking any questions you might have in the chat window here today, we also have an amazing team of mentors who have volunteered from around the world to help out both in the chat as well as on ED, the seminar's Q&A platform. Now, I'm so pleased to introduce in just a moment tonight's teacher, CS50's own Brian Yu. But before we do that, we have a tradition of sorts of taking a group photo, albeit virtually. If you would like to opt into this, please feel free to turn on your camera now. And we need a few moments of waving and smiling in order to take screenshots of all of the different pages of attendees now, since we have over 150 of us all here in the same Zoom room. So meanwhile, while we're waving here, CS50's team behind the scenes is taking a few screenshots. We'll then stitch it together and post it on the website hereafter. And I'm just going to wait for the cue from my colleague Tara to let us know when we can stop smiling and waving. Not just yet, a few more seconds.
Awesome.
There we go. All right, thank you to Tara and the team. So without further ado, our instructor today is CS50's own Brian Yu, who teaches not only CS50's introduction to web programming using Python and JavaScript, but also CS50's introduction to artificial intelligence. So whether you've already taken or are taking or might take CS50, those are just two of the possible courses that you can take even beyond CS50 itself. So without further ado, Brian.
Thank you very much, David. Hi, everyone, and welcome everyone to CS50's New Year's seminars. Today, we're going to be introducing the programming language Python. So if you've never programmed before, this will be an opportunity to see what it's all about and to try some Python programming yourself. While we're introducing Python, if you at any point have questions, definitely ask them in the Zoom chat. You should, near the bottom of the window, see a button that says chat. And if you click on that button, several people I see are already saying hi to other classmates from around the world. You're welcome to ask questions there. I'll be keeping an eye on that throughout today in order to help answer questions you might have. And for any questions I miss, we have a fabulous team of mentors who are in the chat as well, who can help to answer your questions too. A couple things just to get set up before we begin officially. First, if you don't already have a GitHub account, go ahead and head to this URL, github.com/join, to sign up for a GitHub account. You'll use that account to sign in to some of CS50's tools a little bit later today. And for any questions you have where you might want to have more of a discussion about your question, or there will be a couple times today where I'll stop talking and give you an opportunity to try writing some code on your own. If at any point then you have some questions as well, we have a course discussion forum called ED, which you can find at that URL that I just pasted into the chat too. Feel free to go there to ask questions too, and the mentors will be there as well to help answer questions that you might have. And the final link that I'll send you for now is where we'll be spending most of our time today. which is a platform called CS50 IDE, which you can get to at this URL, ide.cs50.io, from which you can sign in with your GitHub username and password. This is where we're going to be writing most of our code today. IDE stands for Integrated Development Environment. It's effectively a tool designed for writing and running code, and CS50 IDE happens to be one that lives in the cloud. So you'll be working in this cloud-based IDE, writing and running your very first Python programs today. If at any point you run into any technical trouble, definitely just ask in the chat and the mentors can try to help you resolve that as well. So go ahead and head to CS50 IDE now and sign in with your GitHub username and password. And once you do, you should see a window that looks something like this. This is what my CS50 IDE looks like, and yours probably looks pretty similar. Along the left-hand side is the file browser. So you effectively have a virtual computer in the cloud here with CS50 IDE, and any files that live in your IDE will go on this left-hand side of CS50 IDE. But if this is your first time using it and you've never created a file here before, it'll probably be empty. But over the course of today, we'll be adding plenty of Python programs here. And so if you ever need to find a program, you can search in the file browser and double-click on that file to open it up. When you do open a file, it'll open up in this top portion of the IDE. This is where your text editor is going to be. This is where you'll be writing most of your Python code, which we'll teach you how to do in just a moment. And then down below, this portion of your IDE is called your terminal window. This is a place where you can type commands and run them inside of your IDE. And this is where we're going to be running our Python programs. So we'll write our Python programs here up above, and then down below in this terminal window is where we're ultimately going to be running those programs as well. So with that, let's go ahead and write our very first Python program. So inside of CS50 IDE, I'm going to go up into the File menu and click on the New File button. So I get a blank new file. And from here, I can save this file. I'll go to File and then Save. You can also use Control-S or Command-S. And I'm going to give this file a name, and I'm going to call the file hello.py, all lowercase letters, and the .py extension at the end of the file name, or .py as I'll often refer to it as, just tells the computer that this is a Python program. .py is just a conventional extension so that we know that this file is going to contain some Python code. So we're going to call the file hello.py, and I'll go ahead and save the file. And now let's write our very first line of Python code. I'll go ahead and write this line here, print, and then in parentheses, and then in quotation marks, the words hello world. So what exactly is this one line of code doing? Well, as you might be able to glean just from reading it, even if you've never read a line of code before, what this line of code is going to do is it is going to print, in other words, display to the screen, the words hello world. So we'll try it, and then we'll talk about it a little bit more. To run our code, we have to go to this bottom portion of the IDE. This again is called our terminal window. And in the terminal, I'm going to first type Python, because I'm going to run a Python program, then a space, and then I'm going to type the name of the file that I would like to run. And so I'm going to run now hello.py. And once I've typed the name of the file, I'll go ahead and press enter, and we see the words hello world printed to the screen. We've now run our very first Python program. And beneath that, after hello world was printed, we see this appear again with this $sign at the end of it. That $sign is just called the prompt. The prompt usually tells you whatever program you just ran, that program's done. And the prompt is now telling you we can run another program now if we wanted to by running Python again, and then the file that we would like to run. So anytime you see that $sign, usually a sign that the program's done and it's okay for you now to run another program. So taking a closer look at what's going on in this one line of hello.py, we have the words hello world in quotation marks. Anytime we have text in quotation marks, we're going to call this a string in programming. A string in programming is just a fancy word for a sequence of characters, something like words or sentences or paragraphs, for example. And we've put this string, the words hello world, inside of these parentheses inside of the print function. So a function, you can just think of as some piece of code that performs some task. In this case, print is a function built into Python itself that performs the task of printing or displaying some text to the screen. And functions in Python, as in many other programming languages, are allowed to take inputs that are used as part of that function. And so here, in between the parentheses to a function, go that function's inputs. And so the input to the print function, in other words, the text that the print function should print, are the words hello world. And so that's why this line of code does what it does. And I'll go ahead and give you a moment to catch up to where I am now, to go ahead and write this in your own IDE if you'd like to follow along by writing print hello world inside of hello.py and trying to run your very first Python program. And feel free to write a question into the Zoom chat if there's anything you're unsure about or would like clarification on. Kira's asking about how you run your Python program. So down at the bottom here in the terminal window, the way I ran this the first time was Python space, and then the name of the file that I would like to run, which in this case is hello.py. There is a little bit of a shortcut. If you're trying to run the same program you just ran, maybe because you want to try it again, or you made some edits to the program and you'd like to try running it a second time with these new edits, you can also in the terminal window press the up arrow key. That will take you to the most recent command that you just ran, in my case, python hello.py, and then I can press return and run the program again. And when I do that, you'll see hello world appear. Parag, you can't just write /hello.py as you might have been able to do with compiled C programs if you've had practice with C. That is not going to work. With Python programs, you will need to say Python, then a space, and then the name of the file, hello.py, at least for now. Sarah's asking about other languages you might have seen. So if you've maybe programmed a little bit in C or Java before, you might be familiar with lines of code that require a semicolon at the end of the line. Every programming language has slightly different syntax. It turns out that while languages like C and Java do require a semicolon at the end of many of your lines of code, in Python, that's not necessary. We can just say print hello world, and Python doesn't require you to put a semicolon at the end of the line. Python's just able to figure out for us that that is the end of a statement. All right, so let's try and write a more interesting program now. We have this function called print that serves the role of displaying or printing something to the screen. It turns out there's another function. In fact, there are many built-in functions that are part of Python itself, but another quite useful one is one called input. And while the print function displays information to the user, the input function asks for information from the user. We're going to ask the user to type something in. And so we'll see how that works right now. I'm going to create a new Python program. And again, I do so by going to File, New File. Then I'm going to save it with File Save or Command or Control S. And I'm going to call this program greet.py. So now I have a second Python program inside of CS50 IDE. And David is asking if we're able to write Python code outside of CS50 IDE. The answer is yes. You could write all of this Python code on your own computer without using CS50 IDE at all. The IDE is just going to be helpful for all of us today to standardize an environment that's already set up for you, so you don't have to worry about setting it up or configuring it, and to make sure that everyone who's attending today's seminar is able to see the same looking environment to help make it easier for us to be able to help you as well. But you could do this outside of the IDE too. So let's go ahead and try the input function. The input function takes some input, and remember that any input to a function goes in between those parentheses. And in between the parentheses, we're going to include a string. Remember, a string is just some text. And I'm going to ask, what's your name? And then I'm going to add a space for reasons you'll see in just a moment. But now I'm saying input, what's your name, followed by a space, and all of that is inside of quotation marks. So what is this program going to do? Well, we can find out by trying it out. I'll go into the terminal window, run python greet.py. That's the name of the file now. I'll press enter. And now the program prompts me. It asks, what's your name? And then a space between where my cursor is and the end of the sentence. So that's why I put the space there, just to make it visually look a little bit nicer. But now I can answer the question. It's asking me, what's my name? I'll go ahead and say, Brian. And now I see the prompt again, remember this $sign, and that means that the program is over. All right, so I now have a program that's able to ask for input, and once I provide that input, the program just ends. Ideally, I'd like my program to be a little smarter than that, do something a little bit more interesting. And in particular, if my program's asking for my name, ideally it's going to do something with my name a little later. Maybe it asks me, what's my name? I tell it my name is Brian, and hopefully my program can now say, hello, Brian, or something like that. I want my program to greet me by name. So how can I do that? We're going to need to add a few pieces to this program. And the first piece is what we're going to call a variable. And a variable in programming you can just think of as a container where we can store information. And so our computer program right now is asking the user, what's your name? The user is going to type in their name. And now we're going to store that name inside the computer program inside of something called a variable. And we get to choose what our variables are called. We can pick whatever we would like to call them. Because this variable is storing a person's name, I'm just going to call this variable name. And so watch how I change line 1. I'm going to say name equals, and then the rest of this line, input, what's your name? So what's going on here? Well, I've created a new variable called name. And then this equal sign in Python means variable assignment. I'm going to assign a value to this variable. So what value am I going to assign to the variable? In other words, what information am I going to store inside of this variable? Well, it's whatever's to the right of the equal sign, which in this case is whatever the user provides when they're prompted to type in their name. So we ask for input, what's your name? We store that inside of that variable called name. And now I'm going to add more lines of code to the program. Our Python programs can have multiple lines, and when we run it, we're just going to run each line of our code one line at a time. So let's go ahead and print out hello, and then a comma on line 2. And then on line 3, I'll go ahead and print name. And notice name here is not in quotation marks. If it were in quotation marks, I'd literally be printing the word name, which is not what I want to do. I instead am just printing name, which refers to this variable that was storing whatever it is that the user typed in. And so now I'll run the program, Python greet.py. It asks, what's your name? I say Brian, and my program now says, hello, Brian. Kyle asks, in Python, is there no need to declare what type of variable you're using? Yeah, so if you're familiar with other languages, you might be familiar with having to specify when you first declare or first create a variable, what type that variable is. Is it an integer? Is it a string? Is it a character, for example? It turns out in Python, you don't have to do that. Python is intelligent enough to be able to infer the type of the variable and just to figure it out as the program is running. If we're asking for input, the user's typing in some text, that's going to be a string. And so name is going to be a string. So it saves us a couple of characters there. Raghuram's asking whether we need to import these functions to be able to use them, these input and print functions. It turns out that we don't. The input and print functions are built into Python, so we don't need to import anything to be able to use it. The idea of importing other code from elsewhere is one that we're going to get to a little bit later today, but for now, print and input are just going to be built-in functions in Python that we can just use right out of the box as we start to write our very first programs. All right, so Gerald's asking an interesting question, which is that right now, hello and Brian are appearing on two different lines. It's hello, comma, and then Brian after that. And that's maybe not what I wanted for this program to do. Maybe I wanted it to all just be on one line, as you might ordinarily write if a human were writing this message, for example, where it's just hello, Brian on one line instead of split up. Why do we think it's split up? What is it about our code that's causing it to be split up? If you have an idea, feel free to pose it in the chat. Yeah, I like Ball's suggestion, and it turns out that that's correct, that the print function just by default automatically adds a new line at the end of every time it prints something. So we print hello, and at the end of the print function, Python's just automatically adding a new line for us because it assumes, maybe reasonably, that most of the time when you print something out, you want a new line at the end of it so that you can print something else a little bit later. And there are ways that we can get around this, and I see a few suggestions in the chat, but perhaps the easiest one for now is to note the fact that functions in Python are allowed to accept multiple inputs. Right now, the only input to the print function here is hello, but I could give this function multiple inputs to have it print out multiple things on the same line. And so instead of printing out in two different print functions, I'm just going to, after the string hello, add a comma, and then name. So now I'm passing in two inputs to the print function, where each input is separated by a comma. And so here now I'm printing hello, and then I'm also printing name. And let's try running this program now. Python greet.py, I'll type in my name, and it says hello, Brian. But of course, if I had chosen a different name, if I had typed David, for example, well, then the function is going to say, hello, David. And there were other ways of solving this problem too, and I see a couple other suggestions there too. And that's going to be true a lot of times in programming, that there is not just one way to solve a problem. There are multiple ways you might achieve the same thing. So now that we have this ability to print things out, to take an input from the user, and to be able to store them in variables, let's try and do something with this. Perhaps the simplest of computing machines that I can think of is something like a calculator, just a device that can add numbers together, subtract numbers together, multiply or divide numbers, for instance. And so let's try to build a very simple calculator using Python. And so I'm going to create a brand new Python program, file, new file. I'm going to save it as arithmetic.py, since we're going to be doing some math here. And what I'd like for arithmetic.py to do is accept two numbers as input, let the user type in two numbers, and then I would like to add those two numbers together. And so how can I do that? Well, I can use the input function to ask for input. I'll ask for an input called x, and then on line 2, I'll ask for an input called y. Same thing we've seen already, but now I'm accepting two inputs instead of just one. I want the user to type in two numbers, and I'm calling them x and y because it's a convention from algebra, but you could have whatever prompt you like. I'm going to save each of these inputs in variables. I'll call this variable x, and I'll call that variable y. So I've asked for input x and y, and now let's go ahead and print at the very end x plus y. Add them together, print it out. So a program that accepts two numbers as input, adds them together, and let's try running it. We run Python, not Greek.py, but arithmetic.py. We're prompted to type in a number x. I'll just type in the number 1, and then I press return. I'm prompted to type in a number y. I'll type in the number 2, and I'll press return in just a moment. But anyone want to predict now what I'm going to see when I press return? If anyone wants to chime in with a guess in the chat. All right, so I'm adding two numbers together. I would like to get the number 3 when I add these two numbers together. 1 plus 2, I know, happens to be 3, and I see a few people saying that. But many of you have seemed to caught on to the fact that there's a bit of a bug. Some of you have predicted this, that instead of getting 3, I'm getting the number 12. Now, 1 plus 2 is definitely not 12, so this is the first example of what we might call a bug in our program, but that's okay. Invariably, as you start to write computer programs, you're going to run into bugs, and when that happens, just means we need to turn our attention back to the code and try to figure out what it is that might have gone wrong. So let's try and figure this out. Anyone have a guess as to what's gone wrong here? Why is 1 plus 2 12 instead of 3? Yeah, and I see a few people suggesting the same idea. I like Karina's phrasing, which is that x and y are strings, not integers. Remember that when I ask for input from the user by way of this input function, what the user is ultimately typing in is some text, a string. And so if we take two strings, the character 1 and the character 2, and just put them together, well, what I get is 1 and then 2, which to me looks like the number 12. So that wasn't what I wanted to do. What's the fix? How do I solve this problem? Even if you don't know exactly what code I need to write, what can I do here to try to solve it? Yeah, Ahmed is saying that somehow I need to convert the string into an integer. I need Python to know this is not just text we're dealing with. It's actually a number, an integer. And the way to do that, it turns out there's another function in Python called int, int. And if I wrap the input inside of int, what that is going to do is take the input and convert it into an integer. So notice this entire input line, input x, that goes inside an extra set of parentheses for the int function. We're asking for input from the user, we're converting that input into an integer, and we're storing that integer inside of the variable x. And lines like this are going to come up multiple times today. So be sure to take a look at that, see if you can understand it, ask me questions if anything is unclear about that. But I'm going to do the same thing with y as well. Go ahead and convert that into an integer. And now let's try it. I'll run Python arithmetic. Let's add 1 and 2, and we get 3, which is what we expect. So it seems like this program is now doing what I would like for it to do. And Python can do more than just add numbers together, of course. I could subtract the numbers with x minus y. And so now I can run this program as 10 minus 2, and we see the answer is 8, for example. For multiplication, I can use the asterisk, which is usually above the 8 key on most keyboards. I can run this again, multiply like 7 times 4, for example, and we're able to now multiply those numbers together. And for division, I can use the slash. The slash I can use for division. And so now I can run this again. Let's try 10 divided by 2, and I see that the answer is 5. And so computers are quite good and quite fast at quickly performing calculations. And so oftentimes in our computer programs, we're going to want our computers to do some math to be able to quickly perform calculations as part of achieving whatever it is we want our program to do. Tutor is asking whether CS50 IDE uses Python 3 or Python 2. We are using Python 3, the latest version of Python. Ahmed asked a good question too about why it is that we're getting this like 0.0 at the end of the number, 5.0, whereas in all the other cases, when I did like 10 minus 2, we just got 8, and that was it, no 0.0. So why is it that we're getting a 0.0 at the end of the number now? Yeah, a lot of people are suggesting something to do with this keyword float. And if you're not familiar with it, float is short for floating point number. And all it means to be a floating point number is a number that potentially has something after the decimal place. And so here we have the 0.0 something after the decimal place, because Python is being a little bit smart. It recognizes that when I divide two integers, it's possible that I might not get a perfect integer number. I could try dividing, for example, 3 divided by 2. And now I'm going to get 1.5, for example, with something after the decimal. So Python knows that when I perform division, sometimes it's going to be the case that I'll have something after the decimal. And so we're going to use a float number instead of an int, where an int or an integer really is only ever going to be like 1, 2, 3, 4, 5, or a negative number or 0, for example. All right, so we've now had the ability to write code across multiple lines. Python runs our code in sequence, accepting inputs, converting types, storing things in variables, making calculations, and printing things out as a result. But where programming really starts to get powerful is once we can have our programs make decisions. Rather than always run every line of code, our programs can get smarter once they can decide what to do, where sometimes if something is true, then we run a certain block of code, and otherwise we run some other block of code, or we don't run any block of code at all. And this ability to make decisions, the ability to decide whether or not we should run a block of code, we call conditions in Python. Conditions are just the ability to ask a question, and based on the answer to that question, decide what code we would like to run. And so let's try that. I'll create a new file. Let's call it conditions.py. And I'm going to start by asking the user for a number. X is going to be an integer input. Please type in a number X. This is not a new line of code. We've seen this exact line of code before. But now here's what I'm going to say. I'm going to say if X is greater than 0, and then a colon. And now when I press enter to go onto a new line, you'll notice that if you're using CS50 IDE, this line will automatically indent itself. And I'll explain why in a moment. But indented, I'm now going to write print positive. So what is it that's going on here? Well, we've asked a question. Is X greater than 0? And if it is, this word if and this colon introduce our condition. Meaning, if X is greater than 0, then we're going to run this code that is indented inside underneath that line that says if. So all of the code that is indented, that tells Python that this code is part of the condition. In other words, it is the code that we should only run if this condition is true, if it is actually true that X is greater than 0. So we can try this. I'll run python conditions.py. I'll type in a positive number, and it says positive. But if I instead had typed a different number, like -8, for example, notice nothing gets printed. We immediately get the prompt again. And so now we're not always running every line of code. We are conditionally running this line of code depending on the result of the condition. We check, is the condition true? And based on the answer to that question, we make a decision about whether we would like to run this line of code or not. All right. So now we have some code for what happens if x is greater than 0. And oftentimes, though not always, when we're writing these conditions, it's helpful to think about what do we want to have happen if that condition isn't true in all of the other cases where the number is not positive. And that in programming we generally call an else. And so on that line 5, I'm going to say else. Notice that this line is not indented. It's not part of the body of the if statement itself. It's sort of separate. To say otherwise, if x was not greater than 0, then also indented, let's print out negative. So here, the logic that I'm going to describe now is that if x is greater than 0, we're going to print the word positive. But otherwise, in all other cases, let's print the word negative instead. And so now I can type a positive number and we see positive, or I could then type a negative number and we see negative. Emily asks a good question. Emily's question is, what about 0? And before I answer that, why don't you all try to answer that too? If I type in the number 0, what's going to be printed? Yeah, people are correctly guessing that what I'm going to see is the word negative. I type in 0, and it does say negative. And so this is maybe not ideal behavior for my program. 0 is not technically negative. It's neither positive nor negative. It's just 0. So what I'd like to do is make my condition a little bit more sophisticated to handle that as well. And the way that I can do this is instead of saying else here, where else means in all other cases do this, I can replace this with ELIF, or elif, short for else if. And this is a way of saying, if the previous condition wasn't true, let me now check a different condition to see if maybe this one is going to be true instead. And so here I can say, elif x is less than 0, then print negative. And else, if neither of those above two conditions were true, then I'm just going to print 0. So if x is greater than 0, we print positive. Otherwise, if x is less than 0, we print negative. Otherwise, in all other cases, we're just going to go ahead and print 0 instead. And so now, if I run the program and type 0, it does correctly tell us that the answer is 0. What if I have non-integers on the number? That's ultimately going to give us an error, actually. So you can watch what happens. If I try and type in something that's not an integer, like I type the word hello, for example, notice that I immediately get this error in Python. And we haven't seen any errors in Python yet, but this is going to be helpful to read for the first time. Value error, invalid literal for int with base 10 hello. So even if you don't understand what all of those words mean, we can tell it's some sort of error about a value related to this int function and related to the word hello. And Python is also helpfully telling us line 1 is the line of the file where this problem is happening. And so we see here on line 1, oh, the problem must be that we're trying to take something that is not an integer, something like the word hello, and convert it into an integer. So that ultimately is going to be an error. All right, so conditions are one way where we can add a lot of very interesting and flexible power to our programs. Another very powerful tool in the programmer's toolbox is that of loops, the ability to run code multiple times. And so imagine, for example, and I'll do this in a new file that I will call loops.py. Imagine I wanted to print hello world, which we've done before, but I want to print it not once, but 10 times. The easiest way to do this is I already have a line of code that prints hello world. I'll copy that and I'll just paste it 10 times. 8, 9, 10. And now I can run Python loops.py, and we see hello world printed to the screen 10 times. This works. My code is correct. It prints hello world 10 times. But I'd argue that this isn't the best way to write the code. It's not the best design for my code. And anyone have a sense as to why that might be? There are multiple reasons why this might be considered poor design. April is saying my code is repetitive. Absolutely. I've repeated myself a lot. And a generally good practice in programming is that if you find yourself repeating yourself a lot, oftentimes there's a better way. Annika is saying my code's not succinct. I'm using 10 lines, which is maybe a lot of lines of code, to do something fairly simple. Parag's wondering, what if the number is really big? If I wanted to print not 10 hello worlds, but 100 hello worlds, I'd have to repeat this many, many times. So instead of doing all of this, I'm going to solve all of those problems by way of something called a loop, which gives us the ability to run some code multiple times. And there are several ways of achieving loops in Python. I'll start with one, which is to have a variable called I, which I'm going to set to 0. And I could have named something else, but I here is going to keep track of how many times have I printed the words hello world. And now here's what I'm going to write. While I is less than 10, let's print hello world, and then set I equal to I plus 1. So what's going on here? I is keeping track of how many times I've printed hello world. And as long as I is less than 10, we're going to print hello world and then update I's value. I is a variable, remember. And so we're going to calculate whatever I plus 1 is and store that inside of the variable I. So if I was originally 0, now we're storing the number 1. If I was originally the number 1, now we're storing 2. And we're going to keep adding to I again and again and again until we get to a point where this condition is no longer true. Once it is no longer the case that I is less than 10, the loop is going to be over. And so this does the exact same thing. We run it and we see hello world printed 10 times. So again, I have this variable keeping track of how many times I've run the loop. I'm going to run the loop as long as that variable is less than 10, and we increase the value of the variable every time. There is a shorthand for this last line that a couple people have noticed. Instead of I equals I plus 1, I could instead say I plus equals 1, which would accomplish the same thing. It turns out that adding a value to a variable is such a common thing to do in programming that there's just a shorthand for it, where I can say plus equals 1 to say go ahead and add 1 to the variable. Just saves me a character or two, but it can be helpful when you're writing some more complex programs. It also turns out there's another type of loop that we could have used here, and it's a type of loop that can be helpful anytime you basically know in advance how many times you want that loop to run, and it's a loop called a for loop. And it looks a little bit different, but the idea is very similar. The way a for loop works is like this. For I in range 10, print hello world. Range 10 here is a function that gives you 10 numbers. It turns out they start at 0, but we'll get to that later. We get 10 numbers. And now for each one of those 10 values, in other words, 10 times, we are going to run this code. We're going to run the code that prints the words hello world. And this too does the same thing. It now prints hello world 10 times. And I could change this number, maybe 5 instead, and it'd only print hello world 5 times. And so this is often a useful way to structure your code, just to make it a little more concise, to very quickly create a loop if you know exactly how many times you want that loop to run. If I did range 3 instead, then instead of printing 5 hello worlds, we'd only be getting 3. We can even use this opportunity to accept input from the user. I can say n is going to be an integer input, where the user types in a number. And now, instead of repeating 3 times, let me instead repeat n times. That way, whatever the user types in, that's how many times I want to repeat. So now if I run this program and say 4, we get hello world printed 4 times. But if instead I run this and say 8, for example, well, then hello world is going to be printed 8 times instead. And so I can control by way of this loop how many times the code is going to run. I'll pause here for questions now about anything we've seen so far about functions, types, variables, printing, loops, or conditions, anything that you're wondering about. Austin's asking, what was the difference between the for loop approach and the while loop approach? In this case, there's basically no difference. They're doing effectively the same thing. There are certain times when a for loop is going to be a little bit easier. Notice it's a little more concise than the while loop. So if we can use it and we know in advance how many times we want the code to run, that's fine. A while loop is often helpful if we don't necessarily know how many times the loop will need to run. We just need to keep running the code until something happens. That tends to be more where a while loop is going to be relevant. Azamat is asking, why is the computer asking us to type in a number? Because we told it to. The Python program is not going to do anything unless we tell it to do so. And on line 1 of this program, I have a line of code that asks the user to type in a number. All right, with that in mind, what I thought we'd do is introduce an exercise for you to work on. And I'll actually, in a moment, stop talking and give you an opportunity to spend a few minutes just trying this exercise on your own. You're welcome to stay in the meeting. We're going to talk about the exercise immediately after. But we'll introduce an opportunity for you to take some of these ideas of writing loops and using functions and using variables and put them into practice. And for a little bit of context, I've been doing a little bit of running lately. And let's imagine, for example, I've been running on 10 different days and I ran a different distance every day. And I'd like to calculate, add up, how much have I run in total? And you are going to write a Python program to help me do that. And here is what we're going to ask you to do. Write a program called sum. So you can create a file called sum.py, for example. And this program is going to ask the user to type in 10 integers, and then you're going to print out their sum. So 10 integers, the user is going to type in 10 integers, and at the very end, you're going to print out whatever the sum is. In a moment, I'm going to stop talking, and I'm going to give you about 10 minutes or so to try this on your own. Create a new file inside of CS50 IDE. You can reference back to the code that we've written together as some hints for where to get started. But try and write this program and get it to work so that the user can type in 10 numbers and then print their sum. If you have questions about anything, definitely feel free to post them to the Ed discussion forum. And I'll paste that link into the chat again so you can see it. It's this URL here. And in order to ask a question, you can click on the new thread button inside of Ed. Go ahead and click on question. And then for the category, choose Python, which is today's topic. And you can ask a question there about anything you're confused about. If there's code that's not working, you can put it there for the mentors to take a look at. And we have a great group of mentors who are here with us today who are going to be looking at Ed and helping to answer the questions that you might have. So with that in mind, I will start a 10-minute timer. You should be able to see that 10-minute timer if you look on my video tile here. But I will stop talking and give you 10 minutes to work on this problem. And in about 10 minutes, we'll talk about the solution so you can see how it is that you could have solved it. So we will see you in 10 minutes. All right, welcome back, everyone. Hope you had a good time working through that problem. What I thought I'd do now, before I show you one way to solve it, I wanted to hear how you all solved it. So if you'd like to offer how you solved the problem, feel free to raise your virtual hand if you're comfortable speaking up. You can find that if you click on the participants button at the bottom of the screen, and you should see a button that lets you raise your hand virtually. And I'd be curious to hear your approach. Not the exact lines of code you wrote necessarily, but just what you were thinking and what you were trying to do. Let's go to April.
Hi there, can you hear me?
I can hear you.
Great. What I did was I initialized a variable called total, and I set that equal to 0. And then I wrote a for loop specifically for I in range of 10. And within that code block, I asked the user to please enter an integer using the input function. I then wrapped that input function within an int function to turn the string into an integer. And then I took that input and incremented total. So I wrote all that on one line. And then at the very end, I just printed the total variable. And that's how
That sounds great.
That's how I got the
Yeah.
answer.
So a lot of great ideas there. So a couple of key insights. One is using some variable that's keeping track of the running total. We're sort of adding up the 10 numbers one at a time, adding them to some variable as we go, which I see a lot of other people in the chat have used similar ideas as well. And the other idea was to use a for loop. We know we're going to be doing something 10 times. We want to ask the user for 10 numbers. So we could have done that with 10 input lines. And I saw some people that went that route as well. But we could be a little bit more concise by way of some sort of a loop to repeatedly ask the user to type in what number they would like to add next. And so I will show you one way of solving the problem that uses similar ideas. Again, with all of these problems, there are many ways you could have solved it. So your solution may not look exactly like my solution does, and that's okay. But just good to see and useful to see what other approaches could have looked like. And so I'll start the same way April started, actually, just by writing a variable called total and setting it equal to 0. I'm going to be summing up all 10 numbers as I go. And at the beginning, there's no number yet, so it's just going to be 0. I want to repeat some code 10 times. And so I'll go ahead and say for I in range 10, recall that that's the syntax for a for loop that can repeat itself 10 times. And then inside that loop, I would like to now ask the user for an integer. So I'll ask for an integer input. I'll say, please type in a number. And just to simplify things, I'll save that inside of another variable that I can call n. So n is going to be a variable that stores whatever it is the user typed in. And then down below, I'll try total equals total plus n. Whatever that number the user typed in was, I would like to add that to the total. But of course, we can simplify that as we saw before with the shorthand total plus equals n, which is really just the same thing. Either way would have been totally fine. And now at the end of that loop, I can print out the sum is, and then the total. So what's going on? I start with a variable equal to 0. That's the total variable. Then I'm going to repeat the following block 10 times, asking the user for a number called n, and then we're going to add n to our running total. And then at the very end, we print out the total. And we can try the program, Python sum.py. I'll type in 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And at the end, I do see that the sum is 55. So that was one way to solve the problem. And I'm seeing in the chat other people's approaches to the problem as well. And there were definitely multiple ways you could have done that. So it does turn out that for loops are quite good for things like this, for being able to run code multiple times if we know how many times we would like the code to run. One use case for while loops, I've seen some people asking about when should I use a while loop instead of a for loop. One use case is generally when you want to run code, but you're not sure how many times that code is going to need to run. It depends upon something, for example. And so we could do an example of something like this, which is imagine we want to ask the user to type in a positive integer. And that might happen in like a bank, for example, where maybe users are depositing money using their banking application, and you don't want them to be able to deposit a negative amount of money because that probably wouldn't make sense. So you really want the user to type in a positive integer. So how could you do that? How could you ask the user for a positive integer? Well, let's create a new file. I'll call it positive.py. And of course, I could just say n equals int input, please type in a positive integer. That would be fine. But the user doesn't have to type in a positive integer. They could type in a negative number, for example, and it would still be assigned to this variable n. And so what I might like to do instead is something like this. While true creates a loop. And remember that a while loop is going to loop as long as the condition is true. And if I literally use the word capital T true in Python, that is just always true. And therefore, whatever loop I'm about to write is just going to keep happening forever. In programming, we call this an infinite loop, a loop that's just going to keep happening again and again without stopping, which ordinarily is probably not a good thing if eventually I want my program to stop. But that's okay. In a moment, we'll figure out a way that we can exit this infinite loop. In other words, break out of that infinite loop, but we'll get there. So we're going to repeat this process of asking the user for a positive integer. And when do I want to exit the loop? Well, I want to exit the loop as soon as the user gives me a positive number. As soon as they give me a number that's greater than 0, then I've got my positive integer. I don't need to keep asking them again and again, and I can exit the loop. In other words, I can break out of the loop. And so I can say if n is greater than 0, then break. And break just means exit the loop. Don't keep running the loop, just exit it now. And then at the very end, I'll print n. So now if I run python positive.py, if I type in a negative number, it reprompts me. Negative number, it prompts me again. 0, it prompts me again. Only once I type a positive number does the loop actually exit. We break out of the loop, and then I'm able to see what the value of n actually is. Ziming is asking whether this T needs to be capitalized, and the answer is it does. Yes, the capital T needs to be there. Python is case sensitive, so the case of each of the keywords does matter. And Aldwin, yes, this is very similar to a do-while loop, if you're familiar with do-while loops from other programming languages. There's no built-in do-while loop in Python, but you can achieve the same idea using something like this, breaking out of a while loop. All right, so let's take a look at some other programs that we might write. It is the new year. The new year has just passed a couple of weeks ago. And tradition on the new year is to count down to the new year. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, Happy New Year. So for fun, let's write a program that counts down to the new year. Seems like a thing we might want to do. I'll create a new file. I'll call it countdown.py. And I'd like for this program to count down from 10 and wish us all a Happy New Year. And the easiest way to do that would just be to say print 10, print 9, print 8, print 7, print 6, print 5, print 4, print 3, print 2, print 1, and then print Happy New Year. And this does work. Python countdown.py. And it has the effect of printing 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and then Happy New Year. But if you've been looking at how I've been writing my code, this should probably strike you as not the best way to write this. What's wrong with the code that I've written? Even though it is correct, it does exactly what I wanted it to do, which is to say count down from 10 and wish us all a Happy New Year. Yeah, April is saying it's repetitive. Jay is saying the same thing. I'm repeating myself. Yeah, no two lines are identical here. It's not like before where I was printing hello world over and over and over again, but I still am being repetitive. I'm still using a print statement to print a number. And even though the numbers are all different, it just so happens that the numbers follow a very clear pattern. They're going down by 1 every time. Emily is saying it's inflexible. What if I wanted to start at 5? Yeah, I was sort of late to the countdown. I wanted to start counting at 5. We'll get to dealing with that problem a little bit later. But yeah, it's a great point. So what can I do here? Well, anytime you find yourself repeating code a lot, a loop is often a good thing to try. So let's try a loop. I want a loop to run 10 times. I can do that via for I in range 10, which is going to loop 10 times, as we've seen a couple of times now. And I, which we haven't really used yet inside of our for loop. But this I is going to take on the role of each of those numbers, each of those 10 numbers that we're going to be looping over. And it's going to be a different number every time. It lets us know where we are inside of this for loop. And so let me just print I so that we're printing out a number. So we print 10 numbers and we print Happy New Year. What is this code going to do if I were to run the code? Any ideas? If I try and run countdown.py now. Yeah, Tom has guessed correctly, and I see that Karina and Jay have said the same thing too, which is it counts up and not down. We get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, Happy New Year, which is maybe not the way that most people ring in the new year. Why is this happening though? This is happening because range 10 recall gives us 10 numbers. And by default, it's going to give us numbers starting at 0 and counting on up. So what are the first 10 numbers starting from 0? Well, it's 0 through 9. Those are the first 10 numbers. And I'm printing out each one of them by printing out the value I. And so therefore, I'm getting 0 through 9 and then Happy New Year. So that's not what I want. What I really want is counting down from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what can I do here? What modification can I make? What fix can I make to this program so that it does what I want it to do? I like Gabriel's suggestion. Gabriel says, I think we might need to print 10 minus I instead. And there are multiple ways of solving it. I see a couple of different suggestions. This is one of them. But 10 minus I is an interesting suggestion. Why is that? Well, I is going to start out at 0. What is 10 minus 0? Well, it's 10. So we print 10. Then I is going to be 1. What's 10 minus 1? Well, it's 9. So we print 9. Then I is going to be 2. So we print 10 minus 2, which is 8. Then 7, 6, 5, 4, 3, 2. Finally, I is going to be 9. What's 10 minus 9? Well, that's 1. And so by doing 10 minus I instead of just I, the effect is going to be we're going to start at 10 and count down. So Python countdown.py. And now I get 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Happy New Year. So this logic now, using just 3 lines of code to do what once took 11 lines, which is to count down from 10 and then print Happy New Year. And I'd argue that this is a better design for a program. Now we have some interesting logic, and this logic you might imagine you could reuse in other places. Maybe I happen to live on the East Coast of the United States and we counted down to the new year, but maybe a few hours later, I would like to have my program also do another countdown for the West Coast of the United States and do the same thing. I'd like to be able to reuse this code. And whenever you find code that you would like to reuse, this is often a case where we can start to now write our very own functions. Remember that a function is just some piece of code that accomplishes some task. And we've been using functions that are built into Python for the seminar so far. We use the print function, we use the range function here, we use the input function. So we've been using a number of different functions. But it turns out we can write our very own functions if there is code that we want to be able to reuse later. The whole point of creating a function is to later be able to reuse that function if we want to. And so let's define a new function. Up at the top of my file, I'm going to say def countdown. This keyword def, D-E-F, is short for define. It says, let me now define a new function. And then I specify what is the name of the function. Usually you're going to name the function after what it is the function does. And so this function is going to count down. So we're going to call it countdown. And then 2 parentheses. Inside of those parentheses will go the input to the function if the function takes any input. Right now, my countdown function is just counting down from 10. So there's no need for any input here. So we'll just leave the parentheses empty. And then much like a for loop, much like a while loop, much like a condition, I'm going to add a colon at the end of the line. And then anything that belongs inside the function is going to be indented. So inside, and I can indent by hitting the tab key. Everything inside the countdown function is going to be indented so that Python knows that these lines are part of the countdown function. So now I have a function called countdown that is going to count down from 10. And once I start writing these functions, it's often going to be useful for me to have yet another function called main. And main is conventionally just a function that is going to be the first function we run when we run the program that takes care of deciding what it is the program is going to do. And so here I'm defining a new function called main. And what the main function is going to do, I'll delete this other line down here, is the main function is going to count down, and then it's going to print Happy New Year. So now I've written two functions. One function just does the countdown. It counts down from 10. And my main function does two things. It first uses the countdown function. It calls the countdown function, to use programmer terminology. Calling a function just means to run that function. And after we call the countdown function, we're going to print the words Happy New Year. And so now let's try it. I'll run Python countdown.py, press return. Okay, strange. Nothing happened. Nothing counted down. Nothing printed. I've clearly done something wrong. And yeah, I see several people answering this in the chat. I never called the main function. Notice that when you define a function, all you're doing is telling Python this function now exists. I'm telling Python this main function now exists. And when you run the main function, here's what you should do. Count down and print Happy New Year. And this countdown function now exists. And when you run the countdown function, go ahead and run this loop to count down from 10. But I'm not actually running any of these functions. I need to, at the very bottom of my file, just say main and then parentheses to say, run my main function. And that's going to trigger the countdown and the Happy New Year. So I'll run it again, Python countdown.py. And now, as I wanted it to be, I get 10 down through 1. Happy New Year. I see a question in the chat. Can you add a line that would consider the time appearance of each number at least by 1 second? That is to say, delay every number by 1 second. Because you're right that I'm kind of cheating a little bit here. Right now, I'm just printing all the 10 numbers all at once. Usually not how people are going to count down. Usually you're going to wait 1 second, 1 second, 1 second after each number. Let's try to do that. Now, I could try to write a function that waited 1 second, but I don't even know where I would start with that. I don't know how I would achieve that. But it turns out that Python has a number of what are known as built-in modules. Modules, think of as just some code that other people have written that we can include in our own program to take advantage of code that other people have already written that have already been problems that have been solved. And so here's how I could do that. It turns out there's a module in Python called the time module that I can access by, on line 1 of my file, importing the time module. Import time says I would like to use the time module inside of my program here now so that I can access all of the code that is part of that time module. And it turns out that there is a function inside of the time module called time.sleep. And here, after I print a number, let me say time.sleep1 to say go ahead, and inside of the time module is a function called sleep. And I would like to sleep for 1 second. 1 is the input to that function, which is why it's in those parentheses. So I'm going to sleep for 1 second after I print out these numbers. And so let's now try to run Python countdown again. Sorry, let me run Python countdown.py. And now 1 second at a time, I see 10, 9, 8, 7, 6, 5, 4, 3, 2. And then after the 1, I see Happy New Year. All right, so I'm counting down from 10. Emily asked a great question a little bit earlier about what if I don't want to count down from 10? What if I wanted to count down from a different number? I want to count down from 5, or I want to count down from 15. Not every countdown is necessarily a countdown from 10. And so I'd like to be able to make my function a little bit more flexible. Right now, my countdown function will always count down from 10. And every time I call the countdown function, it is always going to count down from 10. I can't change that. What I can do to make my function a little more flexible is give this countdown function an input. I'm going to give it an input called n, where n here is going to be a value representing what number I should start counting down from. And so now, instead of counting down from 10, I'm going to count down from n. So instead of using 10, I'm going to replace 10 with n. And now inside my main function, as input to the countdown function, inside those parentheses, I get to specify what I want it to count down from. And I can put the number 10 there to say I would like to count down from 10. And that is going to have the effect of a program that counts down from the number 10. 10 is being provided to the countdown function as the input to that function. And then we're doing the countdown. But if I had replaced the 10 with another number, like 5, then notice without modifying the countdown function, we're going to count down from 5 instead. 5, 4, 3, 2, 1. Happy New Year. And now just for fun, I want to introduce one other module we can use. So we've seen the time module now. It turns out that so far, all of the programs we've written do the same thing every time you run them. This program, if I keep running it, unless I edit the code, it is always just going to count down from 5 and then print Happy New Year. What I might like to do just for fun is to add a little bit of randomness into this program. And randomness can be quite helpful in programs. Imagine in a game where you want to simulate the roll of the dice, for example. You want some randomness inside of your program. And so I can also import random to import the random module into the program so that I can now use random related functions. And it turns out that there is one function that I'm going to use now called random.randint that generates a random integer between two values. So I can generate a random value between, let's say, 5 and 15 inclusive. So 5 all the way up to 15. Just pick a number at random. And we'll save that inside of a variable that I'll call number for now, but you could call it whatever you'd like. And now on line 6, instead of counting down from 5, I'm going to count down from number. And that will introduce some randomness into my program. I'm going to run this program, and this time it's counting down from the number 6. 6 was the random number that it chose. And now I'll try running it again. Now it's counting down from 7. Each time we're generating a random number, and we're counting down from that number. Benisha is asking, how do we know what functions to import? How did I know to import time and random, and that I should be using random.randint and time.sleep? How did I even know that these functions existed? Well, you can do so by reading what's known as the documentation. You can think of the documentation as the instruction manual for these modules and for programming in general. And so there's documentation on Python's official website for the time module and the random module that tells you how to use these functions. It tells you what functions exist, and it tells you how they work. And once you've used them a couple of times, you start to get used to them, and then you don't have to look it up all the time. But initially, you would only know that these functions exist if someone had told you about them, as I'm telling you about them now, or if you had gone to find them yourself. And so random module, for now, we've just seen this one function, random.randint, which now gives us the ability to introduce a little bit of randomness into our program. All right. With that in mind, let's go ahead and try writing another program. I'm going to give you another exercise to work on your own. I'll give you a little more time for this one because it'll be a little bit longer. But here's what you're going to do. You're going to write a game, a guessing game. So you can create a new Python file called guess.py, for example. And your task is going to be this, to write a program that picks a pseudo-random number between 1 and 10. So you can use that random.randint function to just get a number between 1 and 10 inclusive, and then give the user 3 chances to guess that number. Each time you should print some message letting the user know whether or not their guess was correct. So your program might randomly pick the number 4, and then you could guess 5, and your program might say, oh, your guess is too high. And then you would guess maybe 3, and your program would say, oh, your guess is too low. And then you get a third and final guess, and if you guess 4, then your computer is going to say you guessed correctly. But it's not going to be 4 every time. You're going to randomly choose a different number every time to keep the game a little bit interesting. So this is going to be your upcoming task. Write this guessing game program. If you get stuck, if you have a question about any of the code that you're writing or you're not sure how to do something, go ahead and post it to Ed, the course discussion forum. Our team of mentors are there to help answer your questions as well. But you might want to think about what parts are going to be involved here. 3 chances to guess, that sounds like something happening 3 times. It sounds like a loop might be useful there. You know you're going to need some sort of randomness. That's probably going to be helpful. And you're probably going to need some conditions, maybe some variables too, just to help keep track of what's going on. So I'll give you a little bit more time for this. I'm going to set a 15-minute timer to give you some time to work on that. Again, you should be able to see the timer on my video tile here, but I'll give you 15 minutes to work on this. Ask in the chat or on Ed any questions, and the mentors can definitely help you out. But in 15 minutes, we'll talk about how we approach the problem and how we could have solved this problem. So I will see you in 15 minutes. All right, welcome back, everyone. I'd love to hear if anyone would like to volunteer how they approached this problem. What were you thinking about? What types of programming constructs or ideas did you end up using? If you'd like to offer your thoughts, feel free to click on the participants button and raise your virtual hand. Let's go to Divyansh.
Good evening, Brian. The approach I used was I basically used a while loop, then to check for 3 inputs. After that, I just told the user to enter the value, and then I used an if. If the value is equal to the random number generated, then I printed some sort of message like you have found the value. And I put an elif if that was not there, then print this. This was a basic approach, and I managed to increment the value so as to not make it a forever loop.
All right, excellent. Yeah, so some sort of a loop you're going to probably want in order to let the user guess multiple times, and you eventually want that loop to end so that the user is not guessing forever. And then after the user provides some input, a little bit of conditions there, asking if something is true, otherwise, if something else is true, checking to see if the number is too high or too low. Yeah, I like that approach a lot. So I'll show you one way that you could have solved the problem. Again, there were many ways that you could have solved the problem. But this is just one possible approach. And so let's go ahead and open up my IDE, and I'll show you an empty guess.py file. The way most people probably would have started doing this was to begin by importing the random module. You're going to need the random module to be able to generate a random number. And so we're going to generate a random number. And to do that, we can say number equals random.randint 1 and 10. We want a random number between 1 and 10, and that line of code will do it for us. And now we would like to let the user have 3 opportunities to make a guess. So I'll loop 3 times for I in range 3. We'll let the user type in a guess. Their guess is going to be an integer input. They're prompted to type in a guess. I'm storing the integer inside of this variable called guess. So guess is storing whatever their guess happens to be. And now I'm going to have some conditions here, as Divyansh did as well. If guess is greater than the number, then we can go ahead and print out guess is too large. Otherwise, if the guess is less than the number, and again, I'm using ELIF or elif to say otherwise if something else is true. If the guess is less than the number, we're going to print guess is too small. And else if neither of those are true, if the guess is not greater than the number and the guess is not less than the number, well then they must be correct. So we'll go ahead and print correct. And so we could try this program. I'll run Python guess.py. I've been having pretty bad luck with this game, but let's see if I can do it now. We'll guess 5 to begin with. Guess is too large. All right, so we'll go a little smaller. Let's try 3. Guess is still too large, so it's either 1 or 2 probably. Let's guess 2. Okay, got it correct on the 3rd try. So it seems this game is working all right. There is a slight improvement you can make to the program, which is that I took all 3 guesses to get it right. Maybe if the person got it right on the 1st try, you don't want to keep prompting them for guesses as well. So you could have added a break after the user gets it right. Remember, the break is just a statement that exits out of a loop. And so maybe after the user gets it right, you don't want to keep running the loop and keep offering the user more guesses. If they still have guesses remaining, you just want to end the program. Banisha is asking about whether a main function was required here. You could have put this inside of a main function, certainly possible. Generally, if the code is short enough and they're not like other functions that I'm writing, you don't really need a main function, but you certainly could. In this case, it would make a pretty minimal difference between the two. Having more functions is particularly helpful as your code starts to get more complex and it gets longer, just to help to keep things organized. When the code is relatively short, it's less important. All right. So a couple of other things that I thought we'd try. One is that we've now seen functions that can accept input. We've seen a function like the countdown function that is going to count down from a particular number, and we specify as input what that number is going to be. Functions are also allowed to produce output. which is something that we'll explore as well. Let's imagine that we're writing a Python program for a game, for example, and two players have a final score, and you want to figure out who's won the game, which means you need to take those two players' scores and figure out which one is larger. And so let's create a new file. I'm going to call it maximum.py. And what we're going to do is write a function that can take two numbers and figure out which one is bigger, which one is the maximum between these two. Now, it turns out that if you've done a little bit of Python before, there's functions built into Python to do this already for us. We're going to do it by hand just to get the practice with how to do it ourselves. But let's define a new function called maximum that accepts two inputs. We can name the inputs whatever we'd like, but I'll call them A and B. And I would like the output of this function to be whichever of the two is bigger. If A is bigger, then I want whatever A's value to be the output. And if B is bigger, I want whatever B's value to be is the input. And so how could I achieve this? Well, I could have a condition if A is greater than B. But now how do I specify that I want something to be the output? I'm going to use a new keyword that we haven't seen yet, and that keyword is return. Return A means exit the function, and this A is going to be the output of the function. So if A is greater than B, the function is just going to be over, and A is going to be the output of that function. And else, if that wasn't the case, let's go ahead and return B. This way, whichever way, we're going to output the larger of the two numbers, the maximum of the two numbers. And now that we've written this maximum function, I can write another function, a main function, that uses that function. I can ask for two inputs from the user, type in an input X, type in an integer Y. Those two lines of code we've seen several times now. And then I'm going to create a variable Z, which will be set to the maximum of X and Y. I'm running my maximum function, passing in those two inputs as my inputs to the maximum function. And whatever the output is, whatever is returned, that's going to get saved inside of the variable Z. And so now I can print the maximum is, and then Z. Aldwin is asking, what happens if A and B are the same value? If A and B are the same value, then A is not going to be greater than B. So we'll hit the else case and we'll just return B. It turns out if they're the same value, it doesn't really matter whether we return A or B because they're the same. Either one would have been acceptable. And so in this case, I'm just returning B. So I'm calculating the maximum, saving the maximum in Z, and then printing out what the maximum is. Again, because I have a main function, I need to be sure to run or call the main function down here. And now I can say Python maximum.py. I can type in two numbers, 2 and 8. And my program says the maximum is 8. There's a question in the chat, do we need the variable Z? We don't technically need the variable Z. I could take maximum X and Y and literally plug that into the print function here. And this would do exactly the same thing, a little bit more concisely without the need for an extra variable. That would have been fine. Just to make things clearer and to put things into multiple distinct separate steps, I added one step for just calculating the maximum and then one more step for printing it out. I'll pause here for any questions. All right, so let's try a few more examples then of what we can do with functions, what we can do with loops, and just a little more of what the Python syntax allows us to do. Before we do, Kira's asking what the colon does. Effectively, you'll use a colon anytime you're introducing a new block of code. So colon goes at the end of defining a function to say this new block of code that's coming, this is the body of the function. It comes after a condition to say all the code that comes next, this is the body of the condition, the code that we should run if the condition is true. And we also see that colon at the end of a loop, like a for loop or a while loop, to say whatever code comes next, indented, that is all going to be code that is part of that loop. All right, so the code that I'm going to introduce now is I would like to be able to do a little bit of very simplistic computer graphics and plot a user's score. Here we've been able to calculate the maximum between two scores. Now I want to just do a bar chart of user scores. That if a user scores 5 points, I want a horizontal bar that is 5 characters wide. And I'm just going to pick a character like the hash mark to be the character that I'm going to use as the symbol that makes up that horizontal bar. So I'll create a new file. I'll call it scores.py. In preparation for what I'm going to do a little bit later, I'm going to define a main function first that I'm going to later call. But here I'm going to ask the user for a score, which will be an integer input. Please type in a score. And now what I'd like to do is for each point the user has, I would like to print one hash mark in a horizontal row. And so how many times am I going to loop this process of printing a hash mark? Well, it's however many times score is, whatever number score happens to be. So I can say for I in range score, print the hash mark. So I'll try this now. Python scores.py. I can type in a score. I'll type in like 5. And all right, I do see 5 hash marks. That's what I expected from this program. But they're vertical. They're not horizontal. Any idea why that might be? I wanted to just print hash mark 5 times. Yet somehow these are ending up vertical. What's going on here? Yeah, I mentioned this a little bit before. Print is automatically adding a new line. Every time I call this print function, which in this case happened 5 times, we added a new line to the end of it. And print was just doing that by default. The solution to this, which we haven't seen yet, but a couple of people have suggested, is that I can override in the print function what comes at the end of the print. Rather than a new line, I can say, after the end of the quotation mark, a comma. This is going to be another input to the print function. And I can say end equals, and then I'm just going to do 2 double quotation marks with nothing in between. This is what we call the empty string. It's a string, some text, with no characters in it, just empty. And what this is telling the print function is that when you're done printing, don't add a new line at the end like you usually do. Just add nothing at the end. Just add nothing. And so let's try that. I'll run python scores.py. I'll type the number 5. And now we do see 5 hash marks all in one row, which is what we wanted. Now, admittedly, a little bit strangely, the prompt appears immediately after that, whereas normally so far today, we've been seeing the prompt appear on a new line, and that was not the case here. But as April is suggesting, we can just add another print after the loop and put nothing in between the parentheses. This is going to be a way to just say print nothing, but let's just print a new line, because print by default will print a new line. And so that's definitely something we can do as well. There are other ways of achieving this as well. I'm seeing some other suggestions that are offered in the chat that you can certainly try to do as well. This is just one way of solving the problem using mostly the tools that we've already seen. So I can try this again. Python scores.py, type in the number 5, and now I do see 5 hash marks all in a row. Shilpa's asking how print behaves as opposed to the way the printf function behaves in C. Not to worry if you haven't seen or programmed in C before, but if you have, the printf function in C, which is very similar, does not add a new line at the end. If you want a new line, you have to put it there. That is in contrast to Python, which does put the new line in there by default, unless you explicitly tell Python, I don't want anything at the end of the print. All right, so this prints out 1 bar for 1 user. But my whole goal of this was to print a chart for multiple users. So instead of just calling this score, I'm going to call it score1. And I'm also going to have a variable called score2, which will be an input, and score3, which will be another input. And now I'm going to print the bar for score1. And since I already have this logic for printing a bar, let me repeat myself. I'll print the bar for score2, and I'll print the bar for score3. So now when I run python scores.py, I can do 2 and 8 and 5, and I see 1 bar with 2, 1 bar with 8, 1 bar with 5. And all right, I see multiple people commenting to me once again that I've got a bit of a problem I've got a problem with some repetition in my code, that I've got this code repeated quite a bit. This is an opportunity to try and improve the design of the program, and I'm going to choose to do this by way of a function. I'm going to define a new function, as Layla has suggested, which is just going to serve the role of printing these hash marks. So let me define a new function. I'm going to call the function print score. It's going to take some input. It's going to take as input a number n, which is going to represent how many hash marks do I want to print. And so now, instead of printing score 3 hash marks, let me have a loop that runs n times for I in range n. Let's print the hash mark with nothing at the end. We've seen that line already. And then just print a new line. It's the same as this code here. I just replace score 3 with n to make it a little bit more generic. And so now, instead of all of these repeated loops, I can just call this function. I can say print score 1, then print score 2, then print score 3. And that will have the effect of calling this function, and each time it is going to run this code. So this is one of the benefits of a function. It gives you the ability to reuse code later, such that if I want to use it 3 times, I can do so. And so now I'll try it again. 2, 8, and 5, and we do see that chart printed. Even though we only wrote this printing code once, we're running or calling this function multiple times. So here we've seen now loops used again, and then end being used to print nothing at the end of the line. Let's do a little more with printing and loops. You might have in grade school, for example, done your multiplication tables where you had to learn all your multiplication facts. You had to learn 2 times 3 and 2 times 4 and 2 times 5. Let's write a program that can help us with that, help by printing out a couple of multiplication facts. So I'm going to create one more file. We're going to call the file multiplication.py. And before I write a main function, I'm going to write a function called multiply, which is just going to print out what I get when I multiply 2 numbers. It's going to accept as input 2 inputs, x and y. And the first thing I'm going to calculate is the product of those 2 numbers. In other words, what do I get when I calculate x times y? And now that I have those 3 pieces of information, x, y, and what I get when I multiply them, I would like to print out all of that information. So let's try this. I'm going to print. And you'll have to follow along a little carefully because this print function is going to have multiple inputs. I'm going to print x, then a comma for another input. In quotation marks, the asterisk, the multiplication symbol, then another comma, then y, because we're doing x times y, then a comma, then in quotation marks, the equal sign, then a comma, and then product. Because I want to print out x times y equals whatever the product is. And so let's now use this function in our main function. Inside of main, I can call or run this multiply function. I can say multiply 2 and 3, and then multiply 2 and 4, for example. And I'll call the main function at the very end. And now when I run Python multiplication.py, we print 2 times 3 is 6, and we print 2 times 4 equals 8. I'll pause here to give you a chance to catch up to where I am if you're following along in your IDE. But my question now is, what if I didn't want to just print 2 multiplication facts? Imagine I wanted to print all of the 2 times tables, 2 times 0, and 2 times 1, and 2 times 2, and 2 times 3, so on and so forth. Maybe all the way up to 2 times 9 or something like that. What would that look like? Yeah, I see the suggestion that we could use a for loop. So I could try that. I could say for I in range 10, and now I need to indent this line because it's inside of the for loop. But instead of multiplying 2 and 3, I'm going to multiply 2 and I. Remember that I is going to range over these values from 0 all the way up through 9. And so now when I run this program again, I get 2 times 0 and 2 times 1, 2 times 2, 2 times 3, all the way up to 2 times 9. So that's helpful. But let's try and do this even more. I want even more multiplication facts. And I want not just the 2 times tables, but all the times tables up to 9. All the 0 times everything, and 1 times everything, and 2 times everything, and 3 times everything, and 4, and so forth. What do? Yeah, April is saying nested loops, which Jay has defined for us helpfully as a for loop inside of a for loop. It turns out that we can take a loop, and if we want that loop itself to run multiple times, we can put that loop inside of another loop. And then that loop will happen multiple times as well. And so here's how we could do that. After for I in range 10, let me add for j in range 10, a for loop inside of a for loop. And now instead of multiplying a number times a variable, let me multiply I and j. Yeah, exactly. So how is this going to work? Well, I is going to start out at 0, and then we're going to get 0 times 0, 0 times 1, 0 times 2, because this inner for loop is going to run through all of the 0 times tables. Then I is going to be 1, and we'll get all the 1 times tables. And then I will be 2, and I will be 3, and so forth. And so by way of nested loops, I can do this 2-dimensional calculation, calculating all of my zeros, all the 1s, 2s, 3s, 4s, 5s, 6s, 7, all the way up to 9 times 9, which is 81, and instantaneously, effectively, printing out all of these multiplication facts. So at this point, we now have we've introduced the ability to modify what comes at the end of a print statement. We've introduced the ability to have nested loops if we want a loop to itself to be able to run multiple times. And with that, I'm going to give you one last exercise that we're going to do in this seminar together today. And it's inspired by the game Super Mario. If you've maybe played it before, you maybe seen this grid of bricks. And what you're going to do is to write a program in Python that asks the user to type in a number, like a number n, and you are going to print an n by n grid of hash marks. So if the user types in 5, you'll print out a 5 by 5 grid like this, 5 rows where each row has 5 hash marks in it. Of course, if the user typed in 4 or 9 or 28, you'd be printing grids of different dimensions. And you can call this grid.py, for example. To do this, you'll probably want to be using multiple loops. You'll probably want to be thinking about what comes at the end of your print statements to make sure you're only adding new lines when you actually want to. But I will go ahead and give you 10 minutes to work on this last exercise for today. Again, if you have questions, ask questions in the Ed discussion forum. Ask questions in the chat if you'd like to as well. And the mentors will be around to help you out. I will start a 10-minute timer that you can track by looking at my video tile here. And we will talk about the solution to this in 10 minutes. So we'll see you then. All right, welcome back, everyone. Would anyone like to offer a possible approach to the problem? Some way that you might have tried it. Let's go to Maria.
Good morning to all. I've in terms of algorithm, what we do that we actually when user types in the number, we put n hash marks in a string one by one. Then we go to the next line, and we do it n times. So we got a loop, and inside the loop we put a loop and empty print function.
Great. So the idea of nested loops probably going to come up. And I like the way that you broke it down into our individual pieces. We want to print one row of hash marks, and then we want to repeat that process a number of times for each of the rows. And so I might start this by saying n is going to be an integer input. That's just going to be the number n. That's just going to be the height of the pyramid, for example. And then from there, I could say, for I in range n, because I want to do something n times, and what do I want to do n times? I would like to print n rows, and so now I need to print a row. And so what would go inside of here would be another loop for j in range n, because what is every row? Every row is just going to be n hash marks, and we know how to print n hash marks. We're printing a hash mark with nothing at the end. And then at the very end, I can just say print, to say print a new line. These three lines of code, very, very similar to the code that we wrote for our bar chart of scores not too long ago. The only difference now is that that code itself is going inside of a loop so that we can repeat that process a few times now. So I could try running this, python grid.py, and if I type in 5, I get a 5 by 5 grid of hashes. But if I typed in another number like 4, then I would get a 4 by 4 grid of hashes as well. So again, one way you could solve the problem. I saw multiple different approaches in the chat. And so however you approach the problem, there were definitely many ways of trying to do this. So we've now seen a good number of the features of Python. We certainly have barely scratched the surface. There's a lot more to the language, but we've seen a lot of the fundamentals. And so as we wrap up today's session on Python, we do actually have some homework for you. It's optional, but if you'd like to try your hand at writing some more Python programs yourself, you can try them. The first homework assignment is also inspired by the game of Mario, and it's inspired by this pyramid that Mario climbs at the end of one of the levels. And your task is to do this, to write a program in Python that asks the user to type in a number n, and then print a pyramid of hash marks of that height. So a pyramid of height 5 would be like 1 hash mark on the first row, then 2, then 3, then 4, then 5, with everything aligned on the right-hand side. And so you might think about how it is that you can do that. It's similar to the grid we just made, but a little bit trickier. And the other problem that we'll assign as homework for you is to write a program that asks the user to type in some amount of money and then prints out the minimum number of US coins required to make change for that amount of money. So in the United States, the standard coin denominations are 25 cents, 10 cents, 5 cents, and 1 cent. So if I ask you to make change for 31 cents, for example, you could do so by way of 31 pennies, but the more efficient way to do it would be to use maybe a quarter for 25 cents, then 5 cents, and then 1 cent to use just 3 coins. And so you'll write a program that can figure out how many coins you need to use given any amount of money, and we'll print that out. And as a bit of a hint, when you're deciding what coin you should use next, you probably want to pick the biggest coin. That if you have the option of choosing a larger coin denomination, that's likely the one that you want to choose. As you work through those problems, certainly if you have questions about them or want help, feel free to continue to post on the Ed discussion forum. Even after the end of today's seminar, the mentors will be around to be able to help you out with that too. And if you do go on to take CS50 on edX, know that you'll learn even more about Python, and you'll end up submitting these problems as part of the problem sets that you will complete for that class. Today, as David mentioned at the beginning, was the last seminar that we're holding for New Year's seminars about Python. But there are other seminars on other topics that are coming up later in the month. Starting at the end of this week will be a few seminars about SQL that I'll be leading. All of the seminars in the same topic are the same, so you don't have to attend all 4, but we're offering each at 4 different times so that you can attend hopefully one that fits your schedule. So I'll be leading one on SQL. Kareem from our team will be leading one on Linux after that. And then Colton will be leading one on game development. So if any of those are topics that you might be interested in exploring or learning a little bit more about, we'd certainly love to see you at future sessions as well. But before we wrap up today's session, we would like to get some feedback from you. So if you could go to this URL, and I'll share it on my screen too. This URL here, cs50.ly/feedback. It shouldn't take more than a few seconds for you to fill out, but we always love feedback about what you thought of the seminar, what you thought went well, what you got from it, and what we could do to make the seminars better in the future. So feel free to, we would highly encourage you and ask you to submit that feedback form before you head out today. But after you complete that feedback form at cs50.ly/feedback, that officially wraps up today's seminar. Thank you all for joining, and a special thank you too to all of our mentors who have volunteered to help to answer questions in the chat and on Ed today too. So thank you to all of the mentors for all of your help today and through all of the Python seminars that we've had over the last several days. We hope to see you at some future seminars in the future, and thank you all so much. Bye, everyone.